I'll give you a quick demonstration of a debugger tool called GDB that you'll use in Hack 9, but the week after that. And then with the remainder of our time a week from today, I will bring in the last semester's midterm, and as a review, we'll go ahead and do that midterm right here. I don't generally post the code afterwards, so if you want the code, be sure to follow along. But otherwise, you'll see what the midterm will be like. The midterm is going to be 2 weeks from today. Remember that is the week that you come back from break, so you're off that Monday and Tuesday. Obviously, there's not a class on that Monday. There is not a lab on that Tuesday, but then you'll immediately come back on that Wednesday for a midterm. Likewise, most office hours will probably be closed, but I'll talk to the LAs to see if they're going to be here. Then they can put in the hours, and I believe the SRC will still be open. Yeah.
Will we have a hack that week too?
Yeah, you'll have that's the GDB that Thursday. So midterm Wednesday, and then Thursday. It's a tic-tac-toe program that has several bugs, and you have to fix them. But otherwise, it's a complete program already written. There are just a handful of bugs, and you have to use a GDB debugger to walk through the program to see what's wrong. Right? And I'll show that to you next week. All right, so keep that in mind. So again, today's module, we'll start talking about strings. And the reason that we talk about strings after arrays is because in C, strings are nothing more than character arrays. When we talked about arrays, I mostly kept it to integers and doubles. I never talked about chars, right? What is a char array? Well, it turns out that it's a string in C. Strings generally are ordered sequences of characters. They might be ASCII or Unicode, but in C, it only supports ASCII. You'd have to bring in a library or something else, or a modern extension of C in order to support Unicode. Unicode being non-ASCII text characters. Emojis, for example, are the most recent addition to the Unicode standard set. But otherwise, other script languages like CJK, that's Chinese, Japanese, Korean fonts, Cyrillic and stuff like that, those are all defined in the Unicode standard. C does not directly support that. It only deals with the ASCII text characters because a char is only a value of 0 to 255. Different languages support strings in different ways. Most languages also provide an extensive library for you to use so that you can process strings, that you can work with strings more easily. And C it does provide a string library. It's in strings.h. All right? So let's talk about how you do strings in C. Strings in C. In C, strings are simply just arrays of char elements. Right? However, there's a big difference. Right? In C, all strings, and I'm going to put that into bold here, must end with a special null terminating character. Right? Now, before I give this to you, again, now we've got yet another thing that means nothing, but in a different context. We've looked at null, we've looked at zero, we've looked at void. This is completely different. The null terminating character is /0. Right? That's not a /n. /n is an n-line character. It's not a /o. There is a slash through it. It's a /0. And it has to be escaped. That backslash there is escaping the 0. It's not the character 0. If you were to look up the ASCII text table, let me go ahead and pull one up here just by images. Here we go. Bring it on over here. There we go. Let's go ahead and zoom in on this. All right. If I wanted the actual character 0, where would it be? It's right here. It has a decimal value of 48. It's the 49th character in the ASCII text table. It's completely different. Just like /n, a character, where is it? Line feed, right? That's a completely different character. It has a value of 10. Where is the null terminating character? It's 0/0. So it's the first one before anything else. Okay? How do you get it? Again, \0. It's a special null terminating character. If you do not, so again, this is not the same thing as void. It is not the same as null, nor 0, right? The character 0. The character 0 is something different. This is /0. It is the null terminating character. If a character array, char array, is not null terminated, terminated means at the end of it, there's a null terminating character there. It terminates the string. HELLO, then you have to have a null terminating character after it. If it's not null terminated, then you have undefined behavior. Right? It might be segmentation fault. It might just simply be garbage results. Right? You can, unlike when we looked at arrays, I told you here are static arrays, don't use them. Here are dynamic arrays. But with strings, it's a little bit safer to use static strings. So you can declare and use static strings. Right? Let's go ahead and look at an example here. Char message, right? There is a static string. If I put a size in there, say 50, right? I'm declaring a character array that can hold 50 char elements. So how many real characters would I be able to put in there? 49. Why 49? I always need at least one character for that null terminating character. I don't have to use all 49 of them and then put the null terminating character. I could just simply put hello in there and then have the rest left over, right? So here's how you would do that. I could put in hello world. There we go. Now what would that look like? It allocates 50 bytes, 1 byte per character. And so HELLO space WORLD and then an exclamation point. So there are 12 characters there. And so I would have room left over to do whatever I want. I would kind of be wasting about 38 other characters, except for the fact that I need that null terminating character there. So I'd only be wasting 37 characters. What would it be filled with? Who knows? Just like there's no default value for variables, there's no default value for arrays, it could be complete garbage in there. But the advantage of declaring something like this is that the C compiler will automatically put that null terminating character in there for you. So if you go to print this, say printf, message is equal to %s. Remember, you've been using that up to now to print just static strings. Right? And here's message. Right? There. If I were to print that out, it would only print out hello world with an exclamation point at the end, because it only prints out up until it sees that null terminating character. The null terminating character has no print value, so even if you tried to print it out, it wouldn't print anything because it's nothing. Right? It's the nothing character. Okay? You could also do something like this instead. Instead of putting that 50 in there, let me go ahead and take that out. We did this when we declared that primes array, when we were looking at arrays. And the compilers are dumb, but at least they're smart enough that they can count. A compiler is able to go through here and count up HELLO space WORLD, exclamation point, and it has 12, right? I'm not wrong in that. My math is right. All right, there are 12 characters in there. Does it create an array of size 12? I heard it. It creates an array of size, what? 13. Why? Because it needs that null terminating character at the end. Without it, it's not a string. It's just a character array. Right? Everything in C, all strings in C have to be null terminated. Right? So, in the above, the message array is 13 characters long. Right? You always need at least one character for that null terminating character. Null terminator. Terminator. Sometimes we just call them terminators, right? Once you've created a string, you can also change it. Right? So I intentionally left it with a lowercase h, lowercase w. How can we change that so that it's an uppercase h, maybe an uppercase w? So let's go ahead and change the first character to h. Right? Well, where is the first character located in that array? Message of what? Which index? Where do indexes start? 0. So I would set message of 0 is equal to, now is this correct? Uppercase H. What's that thing on the left-hand side? Message of 0, is that an array of characters? It's just one character. The thing on the left-hand side is just a char element. The thing on the right-hand side, 2 quotes. That's a character array. That's a string. Even though it is, it's only one character, it's still a string. Actually, is it one character technically? No, it is 2 characters. Capital H and then the null terminating character. So this is wrong because there's a char on the left-hand side and there's a character array on the right-hand side. How do I do just a single character? Remember? Single quotes. Right? Single quotes for single characters, double quotes for multiple characters. Right? How would, oh, sorry, only, there we go. Now, how would I change the W to a capital W? Message of what is equal to capital W? How far over do I have to go? HELLO, space, and then the very next one. It's the 7th character, but is it going to be at index 7? Indexing starts at 0. 0, 1, 2, 3, 4, 5, 6. So it would be at message of 6. Okay? Let me go ahead and bring this over to REPL and demonstrate what it looks like. Right, here we go. So here's REPL. Let's go ahead and zoom in a little bit more. Go out. So I've got hello world here. Let's go ahead and print it out. Right? And I'll print out the message hello world. Let me go ahead and add in those 2 modifications where we set the first one to 0, set the last one, or set the the 7th one, index 6, to capital W. And when we do that, we see that the string has been changed. I wonder what would happen if I changed that null terminating character. What if I wanted 2 exclamation points here? Let me try that. Message of something is equal to another exclamation point. Right? I want to add an exclamation point at the end. So we said that there were 12 characters. So if I set the 13th one, which is at index 12, to exclamation point, what happens? I don't know. It works or not? There are certainly 2 exclamation points now, right? What is that, though? Ampersand, or they're at signs, right? That's at sign, at sign. What does that mean? There's garbage in my string. Here's my string. It was of size 13. 12 characters to represent hello world exclamation point, and then the null terminating character. What happened was, when I changed that null terminating character to an exclamation point, I screwed up my string. It was no longer a string because there's no guarantee that there's another terminating character over here. So when it goes to print it out, the way that it prints it out is that it says, okay, here's a character, 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 character. I'm just going to keep printing characters until I see that null terminating character. I erased it. So it never saw that null terminating character at the end. So it just keeps printing. Well, what does it print afterwards? Well, it's just garbage. So it prints it. Eventually, it did terminate here. If you really got to be careful, though, because if you've got a huge chunk of memory with just garbage in it and none of it is that null terminating byte, it's just going to keep on going until it eventually gets to memory that doesn't belong to you, at which point it results in a segmentation fault. So make sure that you're always null terminating your strings. There was a question? Okay, good. Let's try that out. I'll go ahead and put, the question was, what happens if you make it really, really big, right? And let's go ahead and try it again. Now it works, right? Why? Because there was plenty of room, and the rest of it, I just got lucky, and it was all null terminating bytes, right? That's C saving me from myself by putting in a bunch of null terminating bytes for me. It's not always going to do that. There could still be garbage in there. In fact, let's witness that. Let me go ahead and iterate over that entire array and see what's in there. For int I running from 0, I is less than 50, I plus plus. Let's print out every single character in that array. Printf, one by one to a line. What's the placeholder for a single character? %C, and we'll end the line. And then message sub I. There we go. And then I'm going to make it a little bit prettier. Message sub %D is equal to, and let me go ahead and put in I as well. There we go. So that you can actually see 0 through 49. There we go. All right, let's go up here. Hello world. There's that second exclamation point. Nothing, 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 nothing. Looks to me like it put in a bunch of null terminating characters for me. You're not always going to be that lucky, right? But, OK. What if I put in a null terminating character? So let me go ahead and get rid of this, or at least comment it out. I was able to change the H to a capital H. I was able to change the W to a capital W. Let's go ahead and get rid of this so that we're not screwing anything else up. What if I wanted to make it shorter? What if I just wanted hello? Right? Let me go ahead and change message sub. It would be 5. That's where that space is. And let me go ahead and put in that null terminating character. What do you think it's going to print now? It's HELLO, and then I put a null terminating character in there. The rest of that stuff is still there. World, exclamation point, and then a bunch of null bytes. But it only prints up to hello. Because again, the way that it's working is it starts at the beginning of the array, does whatever you need to do, processes each character, until it sees that first null terminating character, and it says that's the end of the string. Right? I could also restore it, right? I could put in, let's go ahead and do this again, but after we print it, let's go ahead and restore it down with an underscore character instead. And you'll see that the rest of it didn't screw up, right? It wasn't deleted, it wasn't wiped out. It was only that one character that shortened up the string temporarily. Once I took out that null terminating character, then it was back to normal. Yeah? Yes, if you wanted to put a space in there, yes. Right? Now, what happens if you try to put in 2? Now, the compiler is going to choke, hopefully. Yeah, because single quotes are for single characters. I put 2 spaces in here. That's not a single character, so that's not compilable. Right? Let me go ahead and put in underscore. OK? So that's character manipulation and how it basically works within a string. This is a notion called mutability. In C, strings are mutable. Right? That is, in general, unless you make them into a const. Right? Remember, a const array cannot be changed. In general, you can always modify the contents of a string. Right? And you can shorten them up. Right? Again, the example that I gave is if I did this. There we go. If I did this, then I'm shortening up the string. So the above example basically truncates the string so that its contents are only HELLO. Right? Okay. Well, yeah, let me backtick that so that it is code instead. Right? The size of the array and the remaining characters are unchanged. Right? Basically, the contents are still technically hello with a null terminating character, world with an exclamation point, and then finally with another null terminating character. Right? So anytime you see that null terminating character, that's the end of the string. Even though the contents of the array itself has more after that null terminating character, C in the standard C library is only going to look up to that first null terminating character. And that's the end of the string as far as it's concerned. Okay? All right. Oh, yeah, go ahead.
So when we entered in like 50 at the top, but there were only 13 characters, does it automatically put that after the 13?
Not necessarily, but that's what REPL was doing. A different compiler, different system could just put in a bunch of garbage. And in fact, if we did it dynamically allocated, which we'll do here in a second, I can almost guarantee you that there will be garbage in there. Yeah? Yes, by taking a substring, and I'll show you how to do that later. It's just going to be a combination of taking a dereferencing by using an indexing scheme, and then if you want to start somewhere else, you need the pointer to. So initially, here's the pointer at the beginning of the string. If you want a string to start here, you need a pointer over here instead. So how do you do that? You jump over here with the index, and then you reference it with an ampersand, and now you've got a brand new pointer that points into the middle of the string instead. Right? And we'll look at that later. Okay. So what happens if it's not null terminated properly? Segmentation fault, undefined behavior, garbage results. And of course, you can also declare dynamic strings. Right? You can always use malloc to create a character array, a char array, dynamically. To have as big of a string as you want. Strings tend to be small anyway, and they're only 1 byte for each one. So you're still abusing the stack space a little bit. You're still abusing that program stack and those stack frames, but it's a little bit less of an issue. But still, if you've got if you want to open up a file for file processing, which is something that we'll eventually do, and the file has, I don't know, a megabyte of data, you're definitely not going to want to put that on the stack. You're going to want to create a dynamic string using malloc and then fill that string up. Right? So here's an example. Say I've got int, let me change this over to C, there we go. Int n is equal to 100. My goal here is, to create a char array that can hold up to 100 characters. Right? So I'll put 100 into n. Okay. It's a good start. How do I use malloc again? I will need, before I did int star array, right? Well, now it's no longer integers. What is it? It's characters. So I need a char star array. And instead of an array, I'll call it what it is. It's a string, str. Right? In fact, I'll call it name. I'll put my name into it. Okay? And I'll call malloc. Right? How do I call malloc in this case? How many characters do you want? I want 100, right? So n times however many bytes a character takes, which is usually only ever going to be 1, but we still want to use that size of macro to be consistent. Right? And then, of course, we typecast it to a char star. Right? Is that going to be able to hold up to 100 characters? No. What's it going to be able to hold up to? 99, because I'm always going to have to leave 1 over for that null terminating character. So what can I do? Just add 1. Right? Or I could have set n to be 101 and then remembered, okay, I'm only going to be able to fit 100 in there. Okay? Now the problem is, how do we store my name into this new string? Well, we could do the following. Name sub 0 is equal to C. All right. Name sub 1 is equal to H. Name sub 2 is equal to... Should we continue in this manner? My full name is Christopher, so no, not the way to do it. All right? So don't do it that way. Instead, what you're going to want to do is you're going to want to bring in the C standard C library. Right? The standard C library has things to do this for you. Right? There are a lot of useful functions to operate and manipulate and process strings in the string library. So what do you think it's called? String.h, right? Something that actually has a sensible name on it, right? So here are some very common, there are dozens of functions, by the way, in the standard C string library. We're only going to look at a small subset of the most useful ones. If you want to learn more about all the other functions in there, and I encourage you to do so, especially as you're doing your homework for strings or your hack for strings, because if you're asked to do something, don't reinvent the wheel, right? Remember, the first thing you ask yourself in problem solving, is this problem already solved? Go to the string library. Is there a string library function that'll do this for me? And if so, then I should use it. Don't do the manual processing like up there where I set it C, H, R, et cetera, et cetera. That's terrible programming, right? So the C standard library has a string assignment operator, which allows you basically to, you can copy the contents of one string into another using strcpy. What do you think that that's short for? String copy, right? But again, if you're thinking about 40, 50 years ago when memory was at a premium, if you could cut out the ing and if you could cut out an O, well, then you did that. Because if you could save 4 bytes times as many times as you used the string copy function in your code, that was huge, right? So it's a shortened version of string copy, okay? And because we want everything to be backwards compatible, we're still living with it to this day. So let me go ahead and bring down the example from above. And what I want to do is I want to copy chras, or maybe my full name, into the name string that I've got here. So I'll use strcpy, right? And I will copy into name Chris Burke. Oops, sorry, Burke. There we go. That's going to copy chras space capital B-O-U-R-K-E, and it's going to take all those characters and it's going to copy them all into the name array. Now the great thing about this is strcpy takes care of the null terminating character for me. The one thing that it does not take care of is setting up the memory for it. If I hadn't set up the memory using malloc right there, what would I be copying into? Some invalid pointer, probably getting a segmentation fault. I made it of size 101. It can hold up to 100 characters. I only copied a few of those characters, right? So I'm kind of wasting this space over here. It's not that big of a deal. But in practice, I mean, 100 bytes, that's not that much. We're not living 40, 50 years ago when 1 byte really meant the difference. But if you wanted to, you could have just allocated just enough space for chras bourke with a space in between and a null terminating character at the end. So this is how you can copy things. All right? It now contains the string Chris Burke. Let's go ahead and come back over here and demonstrate that. And there we go. Come on. And let me go ahead and print it out. Printf, my name is %s and the line. And then I'll go ahead and print name. Right? So this should just print out my name is Chris Burke. Right? Oops. What did I do wrong? Well, it's telling me I don't know of any strcpy function. Why? What do you need to do if you're going to bring in a library? You need to include it. String.h. There we go. And there we go. My name is Chris Burke. What about the rest of those characters? Right? Let's do what I did before and iterate over all of those characters. For int I running from 0, I is less than n, I++. Printf name sub %d is equal to %d and or c and the line, and I and name sub I. Right? Now let's see what's in there. All right. Looks like there's no garbage. There's chras bourke and then a null terminating character there, and then it looks like it filled it up with null terminating characters. Looks like we got lucky. Right? What if we went, I don't know, not up to n, but up to, I don't know, 200? What would we see after the array? All right. Well, so there we go. Whoa. So here's the original string. It was okay all the way up to about 100, and then the null terminating character. If I went past that, what is that stuff? Name 118, bunch of other is Burke, blah 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 blah. What am I doing here? Right? I am clobbering my own memory. Right? Here's my program's memory. It's got the call stack. It's somewhere it's got the heap. What I'm doing is I'm iterating over this string that I allocated, and then I'm iterating somewhere else in memory. It's not seg faulting because this memory still belongs to me. But it contains code, right? If I kept going, maybe I could even get to the actual code here. It'll probably be garbage. Right? Oh, no? OK. I'm going in the opposite direction of the heap space. Oh, there we go. There's the first real garbage there. A little diamond with a question mark in it. What is that? It's just its attempt to take this byte and treat it as an ASCII text character. It's not an ASCII text character, so it's doing the best it can and prints it out like this. Right? I'm sure that there's other garbage in here if I can find it. No, oh well. I can't force it to have garbage today, apparently. And then is Burke, blah, blah, blah. All right. All that stuff is stored in my program stack somewhere or the heap, and so I'm iterating over. I'm possibly I'm reading my own memory, which is perfectly fine. If I start overwriting my own memory, for example, where is that located? Name, blah, 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 is Burke, is 126. So let's go ahead and screw that up. Name 126 is equal to, I don't know, exclamation point. Let's see if we can get that to work. 126, come on. There's that garbage byte again, and then up to 126. Before it was is. That's because this is that string right there that's being stored. I've already screwed up my own memory. Not that big of a deal for a string. You're only screwing up your own strings. But what if I went down all the way to my program code and started rewriting the program code on the fly? You can do that. That's how buffer overflow attacks are executed. It attempts to act. Buffer overflow attacks are programs, malicious programs, that attempt to gain access to memory that doesn't belong to it, so it can inject its own code. And then when, when the operating system comes back to this memory address, it starts executing the code that you injected into it instead. Right? Very, very cool way to attack a machine. Right? And it's very, very common. Right? All right. So again, let's go back over to the notes here. strcpy copies the second string into the first. Right? The first is called the source, the destination, and the second is the source. Right? And the reason that it goes like this, that I am copying from the right string into the left string, is because that's how assignments work. Int a is equal to 10. It takes the thing on the right-hand side and puts it into the variable on the left-hand side. And that's why it's in that order. It takes the string on the right-hand side string, and it copies it into the left-hand string. Okay? All right. But the big issue here is strcpy will assume that the destination string is big enough to hold what you are copying plus the null terminating character, which it adds automatically. So you don't have to worry about it in this case. There are some cases in which you have to worry about the behavior of a string library function and whether or not it does that for you. Okay? All right. Let's go ahead and look at an example here where that's not the case. What if instead I had 10 here? Here's the same program. Let me move this over. Here's the same program, and I'm only going to allocate 10 bytes for my name, which is probably not enough to hold CHRISTO. Let's change it to, just to be sure, Christopher, Burke, Michael, James. I do have 2 middle names. Weird. I know. That's not weird. OK. I'll go ahead and add another one then. Then it will be weird. I've only allocated enough space for 10, or actually 11, because of that null terminating character. Am I going to be able to fit this? Probably not. So what's going to happen here? I don't know. As we saw, I'm only overwriting my own memory. My name is there. It didn't work. Why? It went past 10 bytes, but it couldn't quite get there, so it was undefined behavior. Garbage results. It went ahead and copied Christopher Michael James Burke into that that string. But it ultimately corrupted my memory, and when I go on and print it out, I have unexpected results. I have undefined behavior. I cannot expect my program to continue to run correctly from now on. Right? Yeah? Say what? The question is, can WAL pick this up? No. WAL is is a very basic linter tool. It can pick up on a few things that are common errors, but it can't really pick up on memory issues, as you probably saw in this week's lab. We wrote a program to intentionally have a memory leak. If you ran WAL, it would not have picked that up. That's a runtime thing. Now, there are static analysis tools out there that can try to pick these things up. One of them is called Valgrind, and it is on CSE. You can check it out. Valgrind, V-A-L-G-R-I-N-D. And you can try running Valgrind on your Lab 7 and see if it comes up with, there's a memory leak here. Basically, it's a tool that doesn't just look at your code. You compile your code, and then it looks at the actual program. It runs, it simulates the program, and then keeps track of everything. And it sees, oh, wait, you corrupted memory over here. Stop. Here's a point in your program where it was corrupted. It's not going to catch everything. But that's a nice static analysis tool that you can use in more complex programs. It'll catch a lot of things. It won't catch everything. Okay? All right. Well, what if I wanted to iterate only over the characters up to the null terminating character? Another nice function that the standard library gives you is a string length function. Right? I meant to do 3. There we go. There we go. So unlike other arrays, where with integer arrays, double arrays, you need to do your own bookkeeping. If you create an array of size 100, you need to make sure that you keep in mind that you created an array of size 100. But with a string, it's a little bit different. Because you may not be necessarily interested in this string when it was allocated, it was of size 100. But we're only storing, say, hello in it, 5 actual characters. I could go through with a counter and count up 1, 2, 3, 4, 5. Null terminating character, we're done. OK, the length of it is 5. But there's already a function there to do that. String length, strlen, returns an integer value corresponding to the length of a string, but does not include the null terminating character. Right? So for example, let me go ahead and cut and paste this. Hello world. And if I call strlen on message here, how big would that message be? Yeah?
Does that mean that earlier you added an extra terminating character after hello if you call it string length?
It would shorten it up and give you a different answer. Exactly. It would give you 5 then instead. Yep. Yeah? Yep. Well, I mean, it starts at the beginning, and then it just counts. So if it's HELLO, null terminating, 1, 2, 3, 4, 5, but does not include this one right here. Right? So in this case, HELLO, spaces count, WORLD, and then an exclamation point. How many characters are in there? I think I said 12 earlier, right? So what's stored in the value n? N is equal to 12 in this case. Right? 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. OK, yeah. There are 12 characters in there. Again, it does not include that null terminating character. As somebody else already observed here, if you shorten it up by setting that space to a null terminating character, now the length is no longer 12. Now the length is 5, HELLO. Right? It only goes up to, but not including that first null terminating character. All right? Let's see. OK. Here's a good exercise for us. String copy, or strcpy, only copies one string into another. What if we wanted a way to create a brand new, entirely different copy containing the same contents of a string? What did we call that on Monday? That's a deep copy, right? If you have two pointers pointing to the same thing, that's a shallow copy. Changes to one are reflected in the other, and vice versa. So what you want is you want two pointers pointing to completely different strings so that if you change this string, you're not changing this string down here. Let's go ahead and go over to REPL and do that. Right? Let me go ahead and write a deep string copy function. Right? First of all, what's the return type going to be? You're going to give me a string and anything else that's necessary maybe, and then I'm going to copy that string into a brand new string and give that over to you. I'm not just simply going to copy it into another string. I'm going to create new memory space, then copy it into there, and then give you that new memory so that you will have two strings with the same contents. How do I return a string? How did we return an integer array? Int star. So how do I return a string? Char star, right? Or char star. Right? That's a good debate. Right? Does it pronounce char? Well, yeah, because of character, but feels kind of weird calling it char, so I call it char. Just like, how do you pronounce GIF? GIF? Okay. GIF. It's graphics, right? So it'd be g. Soft G, right? It's not a peanut butter, okay? All right. So how do I take a string? Char star. I'll just call it S or str. But before we do this, am I going to be making changes to your string to make a copy of it? Probably not. How can I advertise the fact that I won't be doing that? Const. Okay. Now, what do? One, I need to create memory big enough to hold a copy. And then two, copy the contents of str into the new copy. And then three, return the result. There we go. So how do I do number one? Well, I'm kind of doing that down. Yep, I'm kind of doing that down here, right? Let me go ahead and cut and paste this and then modify it. So create a memory big enough. I'll call it copy instead of name. Well, there's no n here. How many characters do you actually want? If the other one was HELLO, do I want 5 characters? I'd probably want HELLO and the null terminating character. How do I know that it was HELLO or goodbye, G-O-O-B-D, good, G-O-O-D-B-Y-E, right? How many is that? 7, right? I can't hard code that value. What do I use instead to determine how many characters there are? strlen of string. Now, is that correct? HELLO, 5. I need 1 more, plus 1 times size of char. Okay? Increase the size here a little bit. There we go. 2, copy the contents of string into the new copy. Well, that's just simply strcpy into the new copy, the contents of string. And then return the result. Return copy. Let's test it out. I'll go ahead and restore this so it's Christopher Michael James Burke. And then I'll go ahead and print that out. Let's go ahead and make a char named copy is equal to, what did I call it? Deep string copy. There we go. Deep string copy of name. Right. Then what I'll do is I'll change the copy. So name copy. The first one, I'll just change it to a lowercase c. Right. And then let's see if that worked. We'll print out the name, and then we'll also print out the copy. The original should not be changed. Right? It should still be capital C, then my name. The second one, we changed that one. That should now be lowercase c because I changed the copy. Right? And there we go. Right there, lowercase c, because I made a deep string copy. This is an essential. This is going to be very essential if you have to manipulate the contents of a string for processing or whatever, but you want the original string intact. So what you do is you take the original string, make a deep copy, and then play around with that one, process that one, leaving the original copy unmodified. Okay. All right. So here I'll go ahead and copy over this. There we go. So good exercise, and there's a full full version when we eventually post these notes. Other convenient functions. Other convenient functions. Right. strcpy copies an entire string. Right. What if you don't want to copy an entire string? What if you only want to copy a part of it? So instead, if I've got the string Christopher, I only want to copy my shortened name, just Chris. Right? strncpy copies only a part of the string. Right? It takes an extra parameter n that specifies the maximum number of bytes to copy. Right? So to demonstrate this, I'm going to go ahead and let's see. Let me go ahead and let's do this over here. So I'll leave that in case we want it. But otherwise, I'll go ahead and put in some code here. Ignore that. So there's my full name. I'm going to go ahead and shorten that to just CHRIS. I've created a character array here, just name, of size 6. That's enough to hold it. Now, if I tried to copy full name into name, that would most likely be a segmentation fault. Let's see if it actually does cause a segmentation fault here. Probably not. But name is equal to %s, name. Let's try it. OK. But it didn't do what we wanted, right? It copied the entire Christopher into it. I don't want to do that. So instead, this is dangerous. Let's not do it. I'm going to go ahead and use strncpy. I will copy into name, full name, but I will copy at most 5 bytes. CHRIS, 5 bytes. Let's see what happens. No, that didn't work. Right. Christopher. I'm only a quarter Irish, right? So that doesn't work, right? I was surprised that there's an O here, right? Let's go ahead and try, I don't know, 6. See what that does. Nope, and then Christopher. Right? Say what? I guess it was his last name, but I did know somebody named Christ. There's a senator named Christ or something, right?
I think so.
Yeah. Anyway, so what is it doing here? It's copying at most 6 bytes. So it goes through Christopher, CHRIS, and then it goes over to T and says, OK, there's 6 bytes. I copied that for you. Let's go back to 5. CHRIS, that's what I want. It's copying at most 5 bytes. But what is it doing when it fails? There, now it's failing differently. And it's got that diamond with a question mark in it again, which is garbage. It copied CHRIS, but then what did it forget to do? Or what did it not do? What goes at the end? Null terminating character. strncpy will only copy the null terminating character if it sees it while it's copying. So if I want to null terminate it, it's now my responsibility. Name of something is equal to the null terminating character. Right? What should that be? CHRS 0, 1, 2, 3, 4, and then the last one should be 5. That's where I put the null terminating character. Right? And now it works. Right? It only copies at most however many characters you want to copy over. If it had seen the null terminating character within these 5 bytes that you asked it to copy, let's say it was right here, so it's just CH, and then a null terminating character. It would have copied CH, null terminating character, and then it would have been done. Right? It only copies up to that null terminating character. Right? So the behavior, again, is, let me go ahead and copy the code that we just did. But to understand this, strncpy copies at most n bytes and only includes the null terminating character if it is seen within those first n bytes. Right? if there is no null terminator within n bytes, you must manually put it in, you must manually add it. There we go. That's how I'll put it. Okay? So be careful. We've seen now 3 functions. One of them behaves very well and puts in the null terminated character for you. Another one may or may not. There are other functions that don't do it at all. How would you know the difference? You have to RTM. Remember RTM at this point? Read the manual. You have to read the behavior of how they work. Some of them put in that null terminating character for you. Some of them do it under certain conditions, and yet others don't take care of it at all. Right? So be careful. Read the documentation. Okay? And another one is, another basic operation is string concatenation. So strcpy only copies a string. You can also what's called concatenate one string onto the end of another. Right? So how would you, concatenation, that's taking one string and another string and then shoving them together. Right? Some programming languages support this directly as an operator. For example, if you learn Java, you can take a string and another string and then put a plus sign between them. That plus sign does not mean add this string to add this string. It means take these strings and string them together. Other programming languages do this. Some of them use plus. Some of them use a period. PHP uses a period for its string and concatenation operation. Anything else? Perl does something else. I think Perl is also a period, but I'm not sure. Python, anybody know Python string concatenation? That's weird. Well, I forget what it is now. It's either a period or you just leave it blank. Like if you put a string and a string, it'll put them together. I forget. In any case, string concatenation is more of a manual operation in C. There is a function to help you do it. str, what do you think it's called? If you want to concatenate something. Con? There is a con, but no. Shorten it up, shorten it up, shorten it up. Oh, it could just be C, but I went with cat. Right? strcat. Why? I have no idea. Instead of starting at the beginning and like you just predicted, it was con, they went to the middle part of it and said, oh, it's cat, right? I don't know why, maybe string con conversion, maybe they would have confused it with that. At some point, somebody made this decision, right? And because by virtue of the programming language becoming so popular and so ubiquitous and so used, everybody has to live with their original decision. You'll find that a lot of in a lot of programming languages. That this programming language was started by one person, and they just had to make a decision. So that day they were thinking one way, and all right, well maybe I'll change it later. I don't know. And so they just make a decision. Then the programming language picks up speed. It becomes popular. And now it's really, really difficult to go back and say, okay, well that wasn't the best decision. Let's go ahead and change it, because now it breaks everything that people have built from it. PHP is a prime example of this. It was the brainchild of one person. I think his name was Rasmus Lerdorf. And he made a lot of terrible design decisions. Very, very forgivable, because he basically was doing it for his own personal web page. In fact, PHP stands for Personal Homepage Tools originally. And so he was just putting together a programming language so that he could have a dynamic web page that displayed how many people had visited his web page. And so, of course, if he's just using it personally, personal homepage tools, he's going to do it the way that he wants to do it without much care about now 20 million websites using it nowadays. Right? That may be an exaggeration, but pretty much any content management system, Drupal, Facebook was built on PHP. It still is. It's a compiled version now of PHP. But PHP took off like wildfire. And all of Rasmus Lerdorf's decisions 20-some years ago now, we're still living with those today. Actually, it's 23 years. It was 1995 that he made that language. So you'll see that all over the place. K&R, that's Kernighan and Ritchie made the original C. They made the original libraries. And so at some point they said, call it strcat and go with it. Right? Yeah. What do you mean? Oh, lots. Well, it's there's no consistency in a lot of the internal function names. It's dynamically typed, which is terrible, just like JavaScript or anything else. Every compile time error now becomes a runtime error instead. The base language itself was okay, but they've been just adding and adding and adding onto it and extending it out, and it's just really, really, really bad. There have been attempts to pare it down and change it. The most recent, I think, was PHP 6, which was languishing in so long. I don't believe that they're doing PHP 6 anymore. Maybe it's 5. Nobody liked it, and so they skipped it and went on to 7. And no language is immune from this stuff. You still have Python 2 versus Python 3. It's not backwards compatible for the most part. Lots of people don't want to migrate from Python 2 to 3 because they've got a million lines of code based in Python 2 and they don't want to break anything. So they're still using Python 2, even though I think it's at the end of its life or whatever, right? So you live with you live with the mistakes for a very, very long time, right? One mistake in Java would be checked exceptions, but I'm not going to get into that. Right? All right, so strcat. It takes 2 string arguments, a destination and a source, and concatenates the source to the end of the destination string. Okay. Basically, concatenation is sort of like appending. You have a string, you want to add something to the end of it, and so you append that string to the original string, right? But like strcpy, strcat will assume the destination is large enough to hold what you are trying to concatenate. But fortunately, it takes care of the null terminating character for you. Excellent. We don't have to worry too much about it. Okay. Let me go ahead and go over to character for you. Sorry, spelling errors. That's all right. Let's go over here and let's get rid of this. So I'm going to create my full name based on Christopher, Michael, middle initial M here, and then last name Burke. Right? I've got my first name, last name, and middle initial. I want to put all of those into the big full name string here. Right? My first step is, well, what's in that full name right now? What's in full name right now? I have no idea. Again, there's no default value for variables. There's no default value for arrays. You could get lucky, and especially because it's statically declared here, you could get lucky and the C compiler will fill it with null terminating characters for you, but we can't take that chance. So I'm going to start by copying Christopher into the full name, strcpy, full name, and then first name. Let me go ahead and print that out and see what it does. Oops. Not name, but full name. There we go. There. So it copied Christopher into that full name. Let me go ahead and now concatenate my middle initial to it. strcat onto full name, the end of the full name, my middle init. There we go. And so what will it do? Christopher M. That's probably not what I wanted, though, right? What did I want? A space. How can I concatenate a space? strcat, full name, space, no, space, no. That'll work, right? Because that's a string of size 1 with a space character in it. Will this work? Let's find out. Nope, did not compile. It takes 2 strings, string destination, string source. It's going to concatenate this source into this destination. These both have to be strings. That single character there is not a string. It does not have a null terminating character. It's not a string. Right? So the first version was correct. A string containing the space. And now when I run this, Christopher space M, how would I then go ahead and strcat, full name, my last name? Right. Is that going to give me what I want? Yeah, that's not going to be space there, so cut, paste, go down here. There you go. Right. You can concatenate as much as you want. What if I concatenated a lot? strcat, full name, and let's be a masher here. Hopefully that's more than 100 characters, right? Let's find out. All right, and then, wow, exit status 1. That's going to be a segmentation fault. You concatenated, 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 concatenated until you reach that 99 limit with the null terminating character. Then you just kept going. You kept writing memory until you finally got to a piece of memory that didn't belong to you, and the operating system said, nope, segmentation fault. Right? So you are responsible for bookkeeping strings as well. You cannot concatenate more than the string can hold. In this case, it can only hold at most 99 characters. Okay? All right. I'll go ahead and copy this over too. Right? And as a final one, strncat is similar to, oops, I needed to, there we go. There we go. strncat is similar to strncpy. It only concatenates up to n characters. Right? And it also has the same behavior, that if it sees that null terminating character, it'll go ahead and, within the n characters that you want to copy, it'll go ahead and copy it, and it'll be null terminated. If it doesn't see it, then you have to take care of it manually. Okay? We've got enough time. Let me go ahead and show you an example. Let's say, I don't know. I know. Well, that would be ncat. Let me go ahead and just do, instead of my last name, let me go ahead and just get my first initial of my last name. Right? By doing strncat here, let me get rid of this since it'll cause a seg fault. There we go. So my last name here. But instead of copying the full last name, I'm going to use strncat, and I'm only going to copy at most, let's say, just 3 bytes. Right? So let's go ahead and try this. Christopher M BOU. It only copies it only concatenates the first n bytes there. Now you've got to be careful here, because do you see a null terminating character in those first 3 bytes right there? Nope. I just got lucky. It was null terminated already. Right? If you want to be absolutely safe here, then I would need to make full name sub something equal to the null terminating character. Right? What would that something be? I have no idea. Can I use, here's a good question. Can I use strlen of full name like this? So let's say that it was just hello, HELLO, 5. Should I put the null terminating character at index 5? Okay. But strlen, that assumes that you've already got a null terminated character, properly null terminated string. We're asking, that's what we're doing, right? We're asking, how big is this string so I can put a null terminating character at the end of it? Well, that's putting the cart before the horse, or the chicken before the egg, however you want to put it. It's not a null terminated, it's not a valid null terminated string yet, is it? So you cannot run string strlen here, because if you could run strlen here, then it's already null terminated and you don't have to worry about it. So you can't do that. Let me go ahead and, I don't know, how big would it be? Christopher, CH, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, space, 12, 13, 14, 15, 16, 17. So I would want at 17. There we go. Right. Oh, sorry, I miscounted. It should be at 18 then. There we go. Lots of manual adding up, right? You wouldn't want to do that in practice. You would want to, say, call string length in the first one, plus a space, plus the string length on the second one, plus a space, plus 3, plus 1 for the null terminating character. You'd want to do that arithmetic yourself. Okay? All right. Good. One last thing here. Let me go ahead and go back to the notes since we do have time. Substrings. So you can access a string, a character in the middle of a string using indexing, right? For example, if I've got string sub 5, I'm looking at the 6th character, right? Well, how can I look at a string that begins at the 6th character? Right? str is a pointer, right? It's a char star. When you index it, indexing dereferences it. So str sub 5 is a regular old char, right? So what I want, you want a char star. You want a string. So how do I go back to a string that starts at the 6th character? I've already got str sub 5. That gives me this character right here. Right? How do I get a string that starts there? How do I get a pointer that points to that memory location? If it's just a regular old char, how do I change that into a pointer? An ampersand. Right? You can place an ampersand to get the memory address. Right? So ampersand str sub 5. There we go. That's now a char star. But it's pointing to the middle of the string instead. If you went out and printed from there, it would print just starting in the middle of the string all the way to the end. How is this practical? Let me go back over here and let's say, I don't know, Topher. So let's go ahead and do a string copy into full name. My first name, but I don't want to. This would work. This would just print out Christopher. What I want to do is I want to start in the middle at Topher, right? I want my name now to be Topher instead, right? For some reason. Right? How do I get over to that T? 0. Let's see. 0, 1, 2, 3, 4, and then 5. It's the 5th. It's the 6th character. It's at index 5. Right? Now, if I ran this, it would actually probably be a segmentation fault. Okay. It's just a warning. The warning is telling you that this is wrong, and indeed it's a segmentation fault down here at the end. Why? First name sub 5, what is that? It's a lowercase t. A lowercase t has what value? Let's see, where is it? 116. So when I try to copy into this string over here, I'm jumping to memory address 116. Do you think that exists? Or it might. Do you think it belongs to me, though? Nope. Therefore, segmentation fault. And the warning is warning me of that. This is just a char. This is a regular old char variable. If I put an ampersand in front of it, it magically becomes a char star, a character pointer, a string. And when I do this, there, now it only copies Topher. Because you've got a pointer to the beginning of the string. Now, first name sub 5 goes over here to the middle of the string. Putting an ampersand in front of it makes it into a pointer. And so this is now a pointer to the rest of the string, Topher, and the null terminating character. Right? So if you wanted to copy something in the middle, then you could use some combination of string str and cpy along with this substringing, where you use a combination of the indexing and the ampersand out front. Okay? Very, very useful if you want to manipulate strings all day and all night. What we'll look at on Monday is how to process strings in a little bit deeper. Given everybody here has probably worked with CSV files. CSV, anybody know what that stands for? Comma separated value. You've got a comma separated value file. You can open it up in Excel, and you've got a magic Excel. It magically opens up in Excel. You can dump it to a CSV file. How can you do that programmatically? Right? And that's what we'll start covering on Monday. Not Excel, but how to do it in C.